enough for a second half. But thank you. We do have time for 10 o'clock. Oh, wow! You're gonna be next, actually.
I know. That's why I'm losing my nerve.
Oh.
Sorry.
It'll be fine.
What has anything ever been fine when someone said it was fine?
I have a thermos full of coffee. I need to know if it's killing me.
Alan, I did have coffee. Anyways, my presentation is on the H index, or the Hirsch index, and it's generally a metric that evaluates a scientist's, I suppose, credibility in the world of research. It's based on, like, to oversimplify this entire complication, it's based on how many times the scientists publish a paper, how many times did their colleagues cite them, and how many times did it appear in a major magazine like Nature or a scientific journal. And there are some merits to having this metric. However, in my presentation, I may be trying to explore why it is this isn't really a great metric, as it not only creates some very strange incentives or disincentivizes people from innovating, it also stagnates science by creating an over performance-driven environment. So my first slide, I want to show a very real situation that kind of was born out of the H index. So in 2009, there was this famous case called the citation cartel in Brazil. And what happened was there were a ton of graduate students who were figuring out, hey, we're having a lot of issues with funding. We're having a lot of issues getting grants for our university. How do we blow up our credibility? How do we blow up our H index numbers? And they use this method called cross citations. Cross citations, for most people who don't know, is when you just cite your colleague's name, like you're using the work of your colleague in your own research, right? So say I am someone who wants to blow up my H index. I would say, hey, I have a friend who works with something science, like some kind of the same research, but not quite. I could put their name in my research, and they will say, hey, I know Cloud is working something similar, and I will put their name on my research, even if it has nothing to do with, anything. So then it, when you kind of keep citing your colleagues' name in your research, it actually blows up their H index, because as mentioned, part of the equation was how many times did someone use your research. So there are ways to artificially blow up the H index, and this was actually never caught up until 2009, and that was because the only reason it was caught because someone created an algorithm that detected how many times did a certain name show up in every single one of these research papers. And while we could say like, hey, this is like, it's kind of their own fault for being so unethical, the thing is, like, we also have to consider that a scientist's career is incredibly dependent on having a high H index number for funding. The second slide I wanted to point out was that the H index kind of incentivizes people to only research on what sells, right? Because this is what's cited the most. This is what's used the most. For someone to stay afloat in their own career as a scientist, you do have to feel concerned about promotion. You do have to feel concerned about, like, whether you're going to get promoted in your job. Are you like going to be able to secure funding for your own lab? Are you going to, is your research ever going to make it to like these really big names? And it creates a bit of a mess because it incentivizes people to only research on what sells. Like, that's partially why we have so many, scientific articles that one year says coffee's good for you, and next year says coffee's bad for you, and then wine is good for you, and then wine is bad for you. Not per se because it actually like makes us healthier or promotes science any further, but this is just what sells, or this is what's popular. This is what journals can reach out to other people with. And that is one argument I would make that it stagnates science. The third and final argument I would make that why the H index isn't really effective at telling you what a scientist is worth is it dismisses a lot of other aspects that goes into a successful research. So Leo Szystak was brought up during my research in the H index, and most people don't know him But he was one of the people who put together the Manhattan Project. His colleagues were like really big mega names like Einstein and Oppenheimer. And like it may be easy to dismiss his contributions because, you know, it's not quite as flashy, it's not quite as like the story of him wasn't as fantastic, right? However, he did play a huge role in the Manhattan Project. He would make sure he was pretty good glue that held it together. He would just read, you know, his colleagues' grants. He would create data. He would just do a lot of like free. He was creating soundboards for advice. He was doing like a lot of these free labors that kind of kept the group afloat and kept it going. And by the H-index standard, he would not be considered a successful scientist.
1 minute
right?
warning.
Like he only published about 30 scientific papers in his lifetime. So there was one researcher that was incredibly interested in the Leo Szilagds of the world, and he was doing a research in Georgia Tech. So the paper could be found under the name Reconceptualizing Stars, Scientific Helpfulness and Peer Performance. In that paper, they wanted to look for names that were often put in the credits, like, hey, this research wouldn't have happened, you know, if this person didn't help. And they often found Leo Szilagds' name in there. And they wanted to identify scientists who played a huge role in their colleagues' success, or set their colleagues up for success. And there were like certain characteristics they identified with. So they found that, you know, the researchers with like Leo Szilagds or helpful, you know, colleagues were 10% way more likely to make a breakthrough compared to lone wolves. And that kind of tells us a lot about what it takes for a research to be successful isn't just like someone who's like incredibly brilliant and just kind of carries the entire team. It's a group effort. There's a lot of other plays and a lot of subtleties that go into like incredibly big scientific breakthroughs, like the Manhattan Project that led to the world's first atomic bomb. So I wanted to summarize my speech by saying, you know, like some of the problems with the H-index is like there's a lot of problems with cross citations. It incentivizes people to research themselves, and it dismisses a lot of host of other aspects that goes into successful research. And it creates situations where your incentives are somewhat misaligned to collaborate or to, you know, challenge yourself and push boundaries. However, while this is the current metric for how a scientist's career is measured, with a community as, you know, solution oriented and, you know, as like problem solving and driven as the science community, I'm fairly optimistic that we can create a much better system that incentivizes people to push boundaries or research a bit further. Thank you for listening.
Okay, thank you. You have any questions? Nice.
Actually, yes.
Yeah, go ahead.
The sound kind of went
Hey,
off, but I
Clara.
don't know
I got a question for you.
if
Can you hear?
anyone's aware.
Can you hear?
Oh, someone muted.
Hey,
Okay,
Cloud.
here we go.
It's muting us.
We have a question for you.
Hey.
We're wondering, or at least I am, how you might apply this to NoiseBridge to motivate people to research things that bring other people in and create stuff to happen. Something.
Honestly, I'm not going to apply the H-index in there. Look at how much is it disincentivizing people from actually trying anything new or bizarre.
Well, I didn't ask you how not to. I said, how are we going to?
I like Farley's idea because it works on, like, you know, self-proclaimed egomaniacs like me, where you are fairly vocal and active about what you're doing, right?
Yeah.
So I also heard from another person in TJ's AA class about the dung beetle, where like when you start working on a project, it usually just starts with like 1 or 2 people, and then more and more people join in, and hopefully we could kind of get that creative spirit and that productivity back that we had in the old space.
Okay, that's going on a t-shirt. Dung beetles.
Dung beetles.
Dung beetles.
Dung beetles.
That was my impression of how like really mega big projects, you know, ever rolled into existence.
Awesome.
That just works.
Super cool.
So Wait,
Yeah, that's why I'm-
wait, question during the,
Yes, he
yeah.
did.
Anyway.
He's been patiently waiting. Oi, what was your question?
Hi, you're on the air. But you were muted, so you're not actually. Hello, caller.
Okay, can you guys hear me?
I can hear you.
Yeah. First of all, I want to briefly bring up how calling a citation crisis from South America a cartel is distinctly racist.
I didn't pick that title. That was written
Yeah,
in
absolutely
Berlin.
not. We just gotta acknowledge how bad that is.
This is
And
yeah. That was in 2009. This is 2022. So it's like, whoops, that was a little bit different.
So-
back then.
my question would be like, I know from like there's certain mechanisms in when you do look for research grants in very large environments. The physics usually does it very well, where basically people are grading research proposals anonymously, and based on how much that matches between other researchers, the projects get evaluated. So it really disincentivizes pushing your guys' project, and it really looks into evaluating more objectively and sort of penalizing non-objective evaluations. Do you see any way where we could take that Hirsch index and make it become a more objective measure?
I
That-
actually don't really know how to design the Hirsch index to make it a bit more fair, make it a bit more objective, like kind of include a lot more aspects of like what is helpful behavior in a researcher, right? Like there's a lot more than to like someone who's making a scientific breakthrough than like how many researchers they've been and how many times did their colleagues cite them. But there were like some proposals, like when I was looking at Wired.com researching it. However, I didn't find one that was like compelling enough to add into the slide. And we also want to point out that when I was doing the research in the H index, this was in 2019. Some things may have changed since then. So some of the information I may have gotten is outdated. However, it doesn't mean per se I am not interested in what disincentivizes people from trying new things or challenging anything in their career.
Yeah, I can I float an idea and you let me know what you think, unless there are more questions.
Real quick, or actually, can we? You can, yeah. We can talk afterwards. We need to get.
Oh yeah.
Yeah, let's.
Bit of a time
do the next
crunch.
one, but thank you, Cloud, for.
I got
Since I have a field day with that. But and next week, I think since my laptop is up, I will now hog the mic for a few minutes myself.
And now presenting TJ with the amazing.
So local, yeah. With I'm going to present myself and my and can y'all online see? Let me share my screen. The purpose of this is to do image similarity for use in localization. Basically, how to make computers see things when they jiggle.
Live stream, maybe?
So this will be fun. But yeah, welcome. Yes. So yes, we'll call it what. So while I run stuff. Oh, I already ran stuff. Okay.
Well, it's saving up.
I have been playing this for so long, of course. As you can tell.
Like all 5 minutes of talks.
So, basically, why is this called Daydreamer? So, as a little bit of background, in order to do a like a robot moving around the space, the best thing for people to do, or a lot of times when you try and find yourself in a place, you actually usually use these things that spin, these little things that spin in a circle. That are called lidar, or radar, or you use a camera, but you're in a really small space and you have to use a ton of images. And that is generally because we map things in robotics. You generally map things along walls, and things like in your horizontal view, like in the horizon. The problem, this is very good for things like, this is very good for things like an empty corridor or an outside environment, but in a place like Noisebridge, things move here all the time. You will never get a stable map of place because tables move, the flash moves, etc. What if, instead of looking around you actually look up at the ceiling? There's not a lot that changes, and there's at least a little bit that you can observe, that you can give your bearings with regards to the rest of the ceiling. So what I did is first, so just to take it back, usually we could do a bunch of ceiling images, but ceilings are boring. And what is fun is numbers. So here's specifically, if you know MNIST, it's a series of handwritten numbers. Someone will convince you that this is a 3, this is a 2, this is 4, and so on.
No idea what that first number is. It's a 068.
Oh. It's a quantum state, yeah.
All of them.
Who knew?
It's also like Kermit.
This is why they want quantum qubits in AI. It's because of quantum in this data. So yeah, what I did was I got something that retrieved. So this first step, I got something that retrieved a random bit or a random image of a certain weight. So I took the MNIST and said, "Oh, I want a bunch of ones," and then it gave me a bunch of ones. Then I decided, well, okay, I'm talking about numbers, but like, where's the ceiling? And I'm like, this is the ceiling. Obviously, if you think about it, this could be, instead of the piping up here, you could see that as like 4, right? This is piping right around that on that side.
Oh.
Yeah, and so here is it's kind of, here's basically a bunch of tiled in this, tiled in a ceiling, so to speak. And in addition to that, I also created something that can just retrieve a random image from this space. So here you see something that's like basically right in the middle. Here. Sorry. Let me scroll up. I forget. So yeah, you see something that's like right in the middle of this above map. It's like basically right in the middle.
Match it up.
Yeah. And
Okay.
now there's a bunch of code, blah blah, not anything stuff. So like that's cool and all. And the next steps we have are the model itself. And I can get into a little bit of like an autoencoder. Basically, the idea is to encode something and decode it, which is not in itself like a very interesting thing. But the idea is the computer will learn, the model will learn to put an image, which is like a lot of pixels, into a smaller encoding. Basically, like it zips up the image. However, when we're talking about this whole thing, we're talking about localization. We're talking about trying to see something, make sure that if it moves around, if you move around slightly, that your image above will be approximately the same. So what you want to do is take numbers and jiggle them slightly and make sure that it's robust to being jiggled. So here are a bunch of jiggled numbers. They're all jiggled the same way. So you have that. And now here's all the VAE stuff. The VAE is the autoencoder. It's variational, which means you take from a sample. This is the loss function that takes this into account, some training. And now at the end, we have this pretty little graph up here. So what is this? This is the encoding, actually, of each of the numbers. So when I'm applying the latent space is like a 2-vector or 2-number encoding. And so you see there's a number right here and a number. This is one of the numbers, this is another of the numbers, and you can see that some of the numbers are actually pretty filtered out pretty well. Since I made it more robust to jiggling, it's not as separated as it normally would have. But yeah, here's a decent representation of different numbers. And think of each of these points as an encoding. So now I go in and I say, all right, so how did I do? So one way to do this, in a fairly non-various way, is to say, okay, let's jiggle a number and say, is this number better than if I just done it randomly? So I take this number, jiggle it, and see, does this return a similar result to this one versus this one, which is going to be a completely different number? So this you see is very similar to this, especially compared to that. And it's actually somewhat closer. So it's a little bit skewed because the axes are way off. But you can see this one is actually a little bit still closer. It is a little bit farther than you expect, but it's still closer than the completely separate number. And you can see here's the average error, the average distance. All right, so here's the average distance, about 0.6, and then 0.77, which is not great, but we can work with it. Here I actually I haven't gotten into this much. This is the kind of stuff I'm preparing for this particle filter stuff. I want to prepare for a future presentation since I'm running out of time. More stuff like that. This is where I would initialize particles on the map. So like the idea is you like throw darts. Here, this is a very organized dart thrower right here. But generally, like most localization methods, you just throw darts on a map and then see how accurate that is. And then I'm like, okay, what dart throws is if I observe an image on the map, somewhere around here, how close are each of the dart throws? You can see it actually picks up that the dart throws around 1 on the closest, with the p equals 0 going off to 2. And the ground truth coordinate was 2323, and the weighted sum here was 2020. So it's a few pixels off, but it's doing pretty well. And that's my presentation. Thank you.
Nice.
Any questions? Yeah.
What are some practical applications to using this?
Yeah. So I should do this, but yeah, the general idea is to anytime where you want to do localization on so to take a step back, what localization is kind of figuring out where you are on a map. If you ever see a restaurant that has a robot, I think Korea now has it. They have this sort of thing, but they have these like rails. They kind of cheat. They basically like put dots on they put markers on the ceiling, and then it can orient itself relative to those markers. But what if the ceiling, right, like this one is very high, and also like what if it gets painted over and stuff like that? You want to have it so you can actually. Well, my idea was to base it on the visual images, like just be able to use the stuff on the ceiling itself as a marker.
Because you want to build up.
Yes, yes, for Mary's land.
Also, I have a question that
Yeah.
doesn't parlay to this. I have to get back home by 10 p.m. Is there any way I could?
Yeah, you want to go up next?
Is that okay with everyone?
I think Kevin was next.
Because I don't want to like.
Yeah.
Celebrate those.
Oh, Kevin, do you want to? So you're slated next. Do you want to give the floor to A?
Yeah, it's probably okay.
And then you can.
Yeah, absolutely.
Yeah, sure.
One
then
more
I-
thing.
oh, what's up?
Can I write the entire, like 148,000 numbers of pi on the ceiling?
That would be.
Why not, right?
Yeah.
Okay, use a machine that would like automatically.
Oh, probably. You probably should get up there.
That would be pretty good. Oh yeah.
Because my thing's actually a video that's 5 minutes long.
Yeah, sure.
Okay.
Yeah, I'll see. Then I'll give my laptop. That should be close enough. But yeah, thank you for having me, and welcome A on stage.
A person who thinks all the time has nothing to think about except thoughts. So, he loses touch with reality
Hey there, guys.
and lives in a world of illusions.
Yeah, there's always lots of cats.
So I can't put the rest of this on my YouTube channel because they're kiddos and I don't want them on YouTube because I don't put them on YouTube until they're like older because the internet, it's a scary, weird place. But I did some interviews with them and they're super smart, and I asked the youngest, I think she's like 5 years old or 4 years old.
Okay, what's the answer like? The first thing that pops up in your head is the right answer.
Right, big complicated question. And she stood there for like a second and she's like thinking in her mind, and I don't even know what the answer is. You know, I'm thinking like some complex like equals MC square type shit, and she's just sitting there and she's like smiling and she's like, she has her hands behind her back and she's thinking, and then finally she's like, love. And I'm like, holy shit, like and then I asked the other little sister, what is the answer to life? And she says, love.
Yes!
Family?
You got it!
And I love that. Kids are so wise that I was thinking something else that's like so much more complicated and like a bunch of words and explanations, and they just answer love.
Ego. It's all about me. It's all about me. That's what ego is. To say that ego is all bad would not be a correct statement. I watched this TED Talk on YouTube called How to Not Take Things Personally, and I'm going to try to explain it as best as I can here. In the video, he basically said that his method for not taking things personally is by using a coin. Heads, well in this case we're going to use $1. Head stands for it's not about you. So he said that like in a soccer game, he was the ref, he was the coach, and people would yell at him and disagree with like his discernment of the game and his scoring system, and he just talked to himself in the mirror and said that it's not about me, it's just about the game. So I don't need to take it personally. He kind of like disassociated himself from the criticisms and negative things that people said to him. And then he said that tails means that it is all about you, which is maybe you have to look in the mirror and maybe there's something about you that's off. Maybe you gotta change and just be like really honest with yourself. I'd say that the latter is way harder, more challenging, and the former is kind of easy if you're a dick. Both are hard to practice in like a positive frame of mind. It's really just about mindset. So how does this come back to ego again? This can come back to ego because you can use your ego in an appropriate way. Let's say that you don't get accepted for the gig that you've always wanted at this company, and to not take it personally would be the right thing to do, because it's not all about me at that point. It's all about them. It's what they're choosing out. You know, they're making a decision. I didn't fit the job title, and so they're not the person I need right now. It's not
all about me. Oh, they didn't like me. All these things. We can all say that that is the negative part of ego, is we make things up in our heads and we think all the negative things, it's all about me, it's all about me. When it's just a complete delusion. It's really all about them. It's about what their intentions are, what their interests are, and what they need. Because half the time, they're not even thinking about you. They're thinking about themselves. Isn't that like it's great. Yeah, I have an ego. And you know, a lot of the time, I think it's all about me and what they think of me. And I'm always thinking that they're judging me, but we're all equal and we're all the same. And if I'm not thinking about you every single second and judging you, then it makes the most sense, and it's probably the most probable that you're probably not doing the same to me. I'm practicing, I'm learning to stay in my own body and be aware of
Your copyright. There's an error message.
What?
Oh, I thought it said something copyright.
Oh, shoot.
You're big on the screen. Ego is dead. Nietzsche was right.
Yeah, ego is dead. It's not about you. It's about the video.
About the version.
Alright, let's try and share this again. Share video.
A person who thinks all the time.
Where were we?
Oh.
I think life,
What one?
Right there.
love. I'll add the self before it, self-love. But simply put, the answer is love.
Okay.
So in my own body and be aware of my own
We
thoughts
have
and look at
Kevin
myself first.
with
And that's self-love. That's the answer that those two wise children gave to me. What's the answer to life? Love. I'll add the self before it, self-love. But simply put, the answer is
I'm
love.
going to propose
So cringy, but it's true.
a new.
But yeah, thanks for watching.
I'm
Peace.
calling Mike here.
What's ego? For people who have a very big ego, is it like a fish in water? Like they can't recognize they have a big ego because just like our fish can't recognize it's in water, they're just so in it.
It's part of it, but that we needed when we were just a little baby. We needed that recognition and attention.
So do you think moms have like the smallest egos because they do a job that doesn't get much recognition?
Part of being a mom, yeah, it's learning to be greatly empathetic.
Got it. Thank you for answering those questions.
Didn't seem like much longer. We have the log for shell vulnerability and log for J, which like a whole bunch of enterprise software. If you could get it to log a certain message, it would go download the code.
That should be a meme, bro. That should be a meme.
So,
What's your ego saying today?
you know, the industry is sort of the past because there's no really clear way forward to solving this kind of stuff. So I've talked to friends in industry who are building devices we're using, and they say that the hacks are so complex that they can barely debug them. And they're rushing to push out like new OS updates to the phones before they can even understand how the exploitability is. And that is specifically in reference to you know, user vulnerability. It's pretty mind-boggling. And so it's a big deal because governments are sponsoring the creation of these attacks. And it's politicians and, you know, other sensitive people who are getting hacked this way. So it's like, it's some James Bond spy shit, absolutely.
Pretty crazy. So it's a big deal. So on a modern device, at least for iOS and Android, everything is pretty much sandbox. So an app on your phone can't compromise the rest of the device. At least that's the idea. And they can't read your files unless you give them access. They can't really do anything unless specifically given access. And that's been really good for the industry, but it seemed like it's time to go further. So what I'm proposing to go further is, like it says here, sandbox the libraries within the app. So this picture here is actually a Node modules folder from a large JavaScript or Node.js application. And each like rectangle, one library. You have like thousands of them in a typical large JavaScript-based project. And they all have their own libraries too. So you don't know what you're running, really, like ever, unless you're using a very simple stack nowadays. And this example is for the Node.js ecosystem, but it's exactly the same almost in any modern software stack. You have the same problem if you're in Python or Swift or whatever. It all has the same pattern. Although Node.js may be a little bit on the extreme there. I don't know if anyone remembers LeftPad. Oh yeah, someone made a package for Node.js, which it added some white space to a string to make it a certain length. It's like one line, and they made a package out of it. So yeah, the Node.js devs like to go crazy, but really the whole industry is kind of crazy. So we're going to sandbox individual libraries. So you'll be able to say, this library here, I'm going to use the log4j library, or I'm going to use an image decoder library, and I'm not going to allow network access. I'm not going to allow disk access. I'm not going to allow access to the rest of my application. And I'm certainly not going to be able to do anything on the rest of the system. So you'll be able to sandbox an entire library, and that'll be great for security. So the way that we should do this is by actually spawning each library into its own process. Processes are sort of the fundamental building block on modern operating systems most of the time. A typical device is running hundreds or thousands of processes already. So they're common. And they're well supported. I think pretty much the only system that doesn't support processes, surprisingly, is actually iOS. The Mac supports it, that's fine, but iOS enforces a limit of one process per application. Very interesting. So you can't like use the fork system call, can't execute a subprocess. You're actually very limited as long as a thread. But what's important for library sandboxing, we need process isolation. We need this memory protection that a process gives you. So let's say you've turned your hundreds of libraries into hundreds of processes. Well, now you have an interesting problem. You need to communicate between all your libraries because they're all calling each other. Now, how do we normally call a library? Well, a function call. But that's not really supported between processes. So you can like communicate over a socket or shared memory or use locks or message passing. Each operating system actually comes with a few different ways of doing it. But what they all have in common is they're actually all really, really slow compared to a function call. So they're not super helpful if you really want your app to be fast. But they do get the job done in terms of security. And one really big problem is that if you have 10 threads in your application and you want to call a library that's running in one process, that is going to bottleneck you. You would almost need to create 10 threads from the other process as well and like have them match and each run their own server. It'd be a real mess, to be honest. So no one really does this today as a way of sandboxing libraries. But there is actually a pattern that exists on every operating system today, which is pretty close to what I think we need, and that is a system call. So a system call is when you have a user application, which is called user space. The user process is actually calling a function in kernel mode.
1 minute.
Which is running in its own address space. So you can think of that kind of like its own process. So we just need to do this between user space processes. Now this does not exist on any operating system today, but it should. And we should add it. If we can make this usable, I think we will use them everywhere because the security and even reliability gains are so huge. Now, we'll actually potentially need new CPU architectures to get this working quickly at scale, because if we're having millions of containers with millions of cross-process function calls, we're going to need the CPU to help out make it fast. So over the last couple of years, Google's been sponsoring open source chip design. So this was actually a CPU design me and some college students made as a test. It doesn't really implement this technology, but it was something, you know, that we were thinking about a bit at the time. Anyway, the chips didn't work to because of a manufacturing error, so I put them on a pizza. They're actual silicon chips containing my CPU. And this is, you know, me tweeting at the fab company that made them. They liked it. So maybe if the chips had worked, you know, I wouldn't have done that. Anyway, we can build this today, or at least something similar, using WebAssembly or WASM. That can replace our sandbox. That can replace our second process. Because WASM is already a secure runtime. And you can delegate privileges or memory to your WASM subprogram. And your app will run slower, but you could probably gain most of the security benefits today if you ran most of your libraries as separate WASM programs. Or, like I mentioned earlier, you can just spawn a bunch of processes and use slow IPC. So I think we should do this because we're going to get secure today and faster tomorrow when our chips are better at this type of thing. And I'm fully confident that over time they will be. That's all I have.
Any questions?
So, in that last example, can you nest WASM environment or like
I think you would probably have your WASM app spawn like a sibling.
okay, but you could basically have each library running separate.
You could do that. You could even nest interpreters. It would just get even slower.
So, and I guess this is a follow-up question.
Yeah.
When you were talking about delegating privileges to your libraries.
Yeah.
So would it be something like the libraries declaring, like, here's the minimum set of features that are permissions I need, or is it I as the user am going to delegate like, which direction is the privileges are, like, request, you know?
I think you could do it both ways. You could create an environment and give it to your library, but your library can also declare what it wants ahead of time. Both probably is the answer.
Any other questions?
Maybe follow up.
Okay.
So, in the log for shell example.
Yeah.
I feel like that, there was like, it's like something like, it just, there was something in log for J that like requested access to like job, the JVM or something, like lists of objects or something.
Oh yeah.
But like, if you have a library that says, hey, I operate files on your CPU, can I have access to your directory? I feel like that, you know, I'm wondering like what granularity is like, can you give things that and still be secure, or if that's maybe a separate security question.
I think you'd want to be as granular as possible. Probably more granular than any actual sandbox or container is today.
Okay.
So very granular. So you could create your log4j container and say no disk, no networking, and that would block the vulnerability right there. And it'll still be able to produce its output.
Oh, cool.
All right, thank you very much, Kevin. I will close. I think that would be our presentation. Those who want to present, we'd love to have you at next 5 months, which is, according to Google Calendar, is June 16th, 8 p.m. is our June 5 month. But that concludes the May 5 month. Thank you, everyone, for your presentations. And have a great evening.